Done, just confirm, sir. Then I will also just quickly run, and then we will switch to next type of inheritance. But if you get a clear idea about single inheritance, other inheritances are almost same, similar. This thing we have a few differences, and we see that, and we try to complete this today. Okay. All of you are clear with this? Is it clear for everyone, sir? Understood? Or any questions on that? Understood, sir? All of you? All of you are done? So we'll just see the example. So just to show you the inheritance concept, okay, I'm using this. You can use Python. You can run with anything, sir. Any idle is fine. PyCharm or idle, even Anaconda is also fine. You can do with Spider as well. Just a minute. Okay. We have tested all this. So I'm taking a class parent. In this, I am declaring two instance variables. So what is that? First of all, a method set values, and then two variables inside that, instance variables. And I am using what is that? I am directly initializing them here. Self.a. You can also input from keyboard. If you wish, you can input from keyboard. That's up to you. Then another one, self.b equal to 20. So we have defined that. And then one more the data. Then just I am printing these values here. I'm not doing anything else. So A is A. Similarly, do it for B also, sir. B is comma B. Set. Okay. Then you take, this is parent. What did I do in the parent? It's a very simple. We just declared two methods and two instance variables with A and B as the instance variables, and one method to initialize them and one method just to print them. Okay, and then here I should say self dot array, self dot, because instance variables we know, right? Wherever instance variable is there, there we have to apply self. Wherever instance method is there, there we have to use this self keyword with that method. All of you know the type, right? Now you declare one more subclass, class B, and inherit parent, you know, right, like this. So in this parenthesis, put this A with the B class. It means this, when you look at this, it means we are inheriting A class to B class. Now you see, I declare a method D of, I take direct sum method, sum, okay. Now inside this I say self dot C equal to self dot A plus self dot B. If I say self dot C means we are declaring it as instance variable. If we directly declare it as C means it is local variable. You know the difference, right? So that's the point here. Okay. Now print that C in the same class itself, same method itself. Print of sum is, let's simply say sum is comma self dot C. Now what do you do right now? Create an object for, now I have, this is how we have to prepare or create parent and child classes. Now what should I do, sir? I should create object for subclass. How do I do? You know, right? We have already had a discussion. Simply it's B space B, then B dot. Now if you see, I created object for B class. Okay, but what I'm going to do? First, I'm going to call set values method on B object. The method of parent I call on B reference. I say that here B dot set values, then B dot get data, and then B dot sum. B dot what? Sum. If you look at this code, this itself will give you a clear idea. What is that time? This variables A and B, I didn't declare in the B class, but I am using them directly in the B as if they were declared in the B itself. But in fact, these variables are declared in the parent, but not in the child. But I am using them directly in the child itself. And this is possible because of inheritance. If you remove this inheritance with B, immediately you can see an error here. If I try to run this program, it will show errors here with this A and B. It will show errors with these two methods as well. Suppose let me run this code. You get an idea. See, you got errors here. Clearly, it's saying what is it? Indentation. First thing is unindent does not match any outer indent. But let me fix it first. Let me fix the indentation. So this is one issue. That is fine now. We fixed it there. Can you see there now? First, with B attribute, with this B object, it's saying it doesn't have method set values. But suppose if I do the inheritance, if I try to put this A inheritance, and then if I try to run this tile, to our surprise, we have data here. Okay, we have a data here. Means what? If there is a relation between a parent to child, then we can have access to the properties of parent to child. Suppose you remove this, then these two are different classes. A is different, B is different. There is no relation. Now, when we don't have that relation, this parent, this child cannot have access to parent properties. Or when two classes are different, when there is no relation exists between two classes. See, in inheritance, in this object-oriented programming, we create relation with inheritance. Inheritance is the proper way of creating relationship between two classes, and that relation we call it as easy relation. We call it as inheritance is always called as a easy relation. I'll just write here. Okay, what is it? The relation here we can call it as a easy relation. These are all common terminologies, sir. Technical words. Easy relation. What is easy relation? Suppose when two classes are there, we can say A is a parent of B. Suppose when we have inheritance, I can say A is a parent of B class, or B is a child of A class. And we technically denote. Suppose you go to some UML diagrams, all that. So this technical terminologies are very useful to you while creating a relationship between, when you create entity relationship diagrams. Okay, this is very useful to you. Okay, because this talks about, when you say is a relation, then you should remember what is that inheritance. When you say has a relation, there is one more relation called, we call it as has a relation. Means we don't directly use this, we don't use this use a and has a in the code, but with the kind of relationship. Suppose if you have inheritance, we assume that is a relation, and has a instance, that there is another way of having access of members one class to another class, that is with has a. In that case, you don't have relationship between these two with inheritance, between two classes with inheritance. But if it is a has a relation, what do we do here is we create object of one class in another class. Of course, in the methods or in the instance code, we class objects of one class in another class, and with that object, we try to access members of that class in the another class. If we try to access properties of a class in another class through its object, it is has a relation. And if you try to access properties of one class to another class through this inheritance, it's a is a relation. Now we are getting a quick idea about is a relation. Here we will also see a small example about has a relation as well after this. Okay, so got this clarity here now? Is it clear to all of you, sir? Tell me. Now what is the point finally? This is the idea about what is that inheritance. Single inheritance. One parent, one child. Understood, no? Yes or no, sir? How about others? Is it clear for everyone? What kind of relationship is this, sir? What kind of relationship is inheritance, sir? Is it is a relation? Got it right? Now, how does has a relation work? I will show the example here itself. So this is the example. All of you are clear, right? By looking at the code itself, we can understand what is that. We are accessing members of parent directly in the child, the variables of parent of A class in the child class B. We can call B as child only when we inherit A. Second thing, on B reference, you are calling methods of A. If you see set values and get data, they are not part of B class. But these methods of A, we are calling on the object of B, and this is possible because of inheritance. Otherwise, it's not possible. And it is applicable even from real life. If father has a car, son can use that. Got it right? If mother has some other jewelry, daughter can use that. Like that. If father has crores of property, son can use that. Got it right? If father has a servant, the same servant can come and work in your house as well. Like that. Just a quick thinking to analyze. Got it right? This is the idea about this one. Now, quickly let us have a quick idea about has the relation, how this works in programming. Might be as you have a doubt there. Here itself, I am just explaining the has a relation so that you understand different types of relations which exist in object-oriented programming. Usually, we have two types. One is a, the other one is has a. When I say is a, you should remember inheritance. But you know, sir, when I say has a, it's not inheritance. These two objects are totally different. And we don't have inheritance here. Of course, remove this. Okay, how do we have access from A to B here? One advantage, the one way is like this, like we can call it like this. How? First, you create object for A class and B class. How do we create? The same way how we have done in the main scope, except the code which we write in the classes and the methods, all other statements which we directly write in the in the scope are part of which method? Main method. All the statements which we write outside classes, outside methods, this entire code goes into main method. You might ask me a question: do we have a main in Python? Yes. In any language, in every language, main exists. I'm not sure about COBOL, whether COBOL has main method or not. Madhu, do you have main in COBOL? Main method.
Oh, it is a kind of a procedure language. It's a procedure division. There are divisions. So there is a division called the procedure division. So the always the cursor, that execution will start from procedure division.
Okay. So like this, like in other traditional languages, it is little different. Correct, right?
Yeah.
But in all these languages, starting from C, C++, Java, even in Python, I will show you in a debug mode that always execution starts with main method. Even in Python, maybe if you directly declare statements outside class or outside function, these statements goes into main method. So that is fine. We'll talk about it. Okay. But now, coming back to the has a relation. Now I want to have access to properties of A class and B class. Now both are different classes. How can I access members of A and B? Then I should create object for A and B here in the method here, like this. Now I can say something like this. How? Instead of self.a here, I can say a.a and a.b like this. Even when I say a.a and a.b, it is as simple as calling with self.a and self.b. I told you, self is something like, it is an object which holds address of same class itself. Okay, it holds the address of a same class. So self is a kind of reference. It's called implicit reference. But here A is explicit reference. If you say self.a or self.b or a.a or a.b, the approach is same, but the way we are trying to access members is a bit different. That's all. But in both cases, we are trying to access members through its object. That's that object of that class. You get my point? So that is the point here. So now you can just self.say. What you can do now? You can run it again. So nothing to worry. I removed calling, which one? I removed calling set values and get data here. But you can do one thing. You should do one thing. Sorry. Here, once after you create a class object, you know very well, we must and should call this set values method. And without calling this method, you know very well, we cannot create these variables inside the object of that A class. So here, if this object should have these variables A and B, if they must be created, then you must call this method at any cost. Otherwise, you get an error. Unidentified variable A, unidentified variable B, or object A doesn't have attribute A or attribute B, something like that. So what should I do now? I should say A dot set values. Okay, this is very important. Now what did I do? I create an object for A class in B class. If you see, I am creating object of A and B here. Then I am calling this set values method here. I'm calling this here. Okay, now once you call set value, you can have access to variables like this, a dot a or a dot b. This will work, right? But without calling set values, if you do this, it leads to an error. Got it, right? Because these variables a and b are created inside the object of a only when you call the set values. You understand me? So what do you do right now? Finally, this is fine now. I can directly run some function, or here I can also call. You want to see what data is there in a object, then you can call get data here itself. And after that, you can carry out your business logic, and then you can print the result. And this relation, where you try to create object of a parent and child, this is, you can call this as a hazard relation. Got it, right? Now, this B has a object, and even A can have B object. When you try to create it like this kind of relationships, we call it as hazard relation. Got it, right? You understand it, sir? And I should do one thing here also. What should I do? Self dot. If I want this to be part of B object, I should say self dot A equal to A. Got it, right, sir? And then again, what is that? Here also, let me just. Here also, what is that I should see? If I want to be part of a B object, otherwise it becomes local, sir. Local variable. If I want to make it a standard hazard relation, then I should say self dot a dot set values. Let's try in this way. Then self dot a dot get data. When you apply self, then it is a proper hazard relation. If otherwise it is a local, even though you create object in the method, it becomes a local variable. Then I cannot say it as a hazard relation. The relation is like this, sir. I'll just show it in a diagram. Let me explain with the diagram. I'll show you. As a relation exists like this. Okay. I have an object like this. Assume that. Okay. Take two objects. Apple. The other one is just an idea. It doesn't make. See, don't worry about the sense here. This is pineapple, or you can take it as some other jackfruit. Okay, call it as a jackfruit. Now, in this jackfruit, I try to keep this apple object. What I will do? I try to create apple object in jackfruit. See here, inside this. Inside jackfruit, I create an object of an apple. This is apple object. Okay, or otherwise even you can type here also. Now what's happening here? This is has a relation. What is it? Jackfruit has a apple. Inside jackfruit, I have what? Apple object. Got it, right? This is called what relation? Has a relation. You get my point? Right. So, or otherwise, the other way of keeping it like this. The other way is like, might be you can just take this thing here. The reference of this this might be assumed that you created an object. This object has some reference, right? Apple has some reference. Apple address might be some 100 like this. Now, and here this is the reference variable of apple, which you created in jackfruit. You create inside jackfruit class like this, method like this, some self dot okay, some f equal to, you say apple like this. Just an idea of it. And you do this method of jackfruit, some method of jack. Assume that this is something like the of some set apple. which I am going to create it in jackfruit. This is in jackfruit class. And I have what object now? I have created object for apple. Now what is going to happen now? First, the apple object is created. It won't exist directly in the same jackfruit. First, it is created like this. And the reference of this one, usually in OOP, what happens is reference of this apple is copied to this. This 100 is stored into this. This is self.f. This becomes f. This block becomes f. I'm explaining here. This is f. And now here that 100 is stored. Means what f is doing now? F is referring to the apple object from jackfruit. Means what is this? Jackfruit has a apple. This relation is called has a apple. Got my point? If it is inheritance, inheritance will be totally different. Do you understand this, sir? All of you get this point now? Can I get yes or no from you? And that is what this is. When I create it like this, A object inside B, it means like we are creating assume that apple as a what is that A and jackfruit as B. What's happening now? That A object is created in. When I create it like this, A object inside B, it means like to be like this. Means the reference of apple will exist in this B object. You get my point? Can I get an yes or no from you, sir? Still, I think I didn't get any response from you, sir. Is it clear or not? Okay, now that is what is. Let me run this, sir, whether this works or not. Because we just done a workaround here. A is not defined. That is just self dot. What should I do now here? Here might be
that is also self.a plus
going self.a.a, right? Self.a.b. Now this should work, right, Madhu?
Yeah, it works.
This is perfect has a relation. This is perfect has a relation. Do you understand this, sir? So this is a very good example of how has a relation works. Yeah, having one class object in another class is nothing but what is that? Has a relation. Like I told you right just now, I have shown with an examples. Does it know? So you can just test this code, sir, all of you. I think if it is clear for all of you, what do you do, sir? Please test it. So having object of one class in another class is known as a relation. Okay. You can test it, sir. Please test this code. And if you have any doubts, please ask. You can test this here. Once it is completed, please confirm, sir. So this is about inheritance, is a relation and has a relation. Okay. Next one. Multi-level inheritance. So I told you, once we are comfortable with one type of inheritance, and this is almost same for all other different types, but with some few changes. Multi-level is an extension to if you do not use self, then they becomes local variables. Okay. So anyhow, you can go. All these sessions are uploaded in YouTube. You can go through that after the class. Okay. So that will give you a clear idea. So now, this is an extension to single inheritance. It's like grandfather to father and father to child and child to grandchild and grandchild to grandchild. Something like that. Multi-level means deriving a subclass from a superclass. And again from that subclass you derive another subclass. And so on. This continues like our generations. Generation after the generation keeps going on like that. That's what we call multi-level inheritance. Like this. Usually, as per UML, this arrow mark should point to the upper side of this one. Usually, people I see sometimes giving arrow mark to the bottom. That is not correct. If B is child and A is parent, this arrow mark should be upper arrow mark between A and B. That is a perfect UML diagram. Okay? So you can see it anywhere. If arrow mark is pointing to the top means it is a parent. And the bottom one is a child. Like if it is reverse means then B is child and A is B will become parent and A will become child, like that. To whichever the class arrow mark is pointing, that is always a parent. Keep in mind. Okay? Now, in multi-level inheritance, a bottom level class, a grandchild have access to all its parents' classes, all its top level classes. Like if you talk about Naga Chaitanya, he has properties. He will have access to properties of his father Nagarjuna, and also as well as Nageshwar Rao. If Nageshwar Rao father's properties were there, even that can be acquired by Naga Chaitanya. Just an idea. So a bottom level class has access to all top level classes except private properties. Of course, if a father or grandfather has something private, purely private, they are not accessible to you. But public and protected properties are accessible. Okay. So that is the idea about the multi-level inheritance. What you do is take a small example. Let's extend this previous program. The previous program, what did we do? Declare a parent like this AB, and then set values and display. Use the same class and B. And in the B class, in the previous example, we find some and take one more class C, extend it from B. In the B class, try to implement you do the product. Now, how do you do the product in C class? Use the properties of AB from A class and C from B class and do product of all those three variables in C class. And now if you create object for C, C can have access to methods of B as well as methods of A and variables of B as well as variables of A. Through C object, you can have access to all that. If you wish to create object for B and C, it's up to you, sir. But if you just create object for C, it's sufficient for us. Okay. So what do you do right now? Just take this example, do it, complete it. Okay, finish this. Take some time, 2 or 3 minutes or 5 minutes. Finish this. This is idea about multi-level. Here we'll go level by level, but we restrict usually in a real time. We don't take too many levels, so we try to reduce number of levels as possible so that it will be effective and efficient. That is also important. Okay? So please develop a program for this requirement just to understand how multi-level inheritance works in this object-oriented program. Okay? Right. I have pasted all that notes, whatever you have done today. Anyhow, I will share the file as well if you want. This is already there in GitHub. Just for filing notes, I am sharing this with you. Okay. Okay. Just confirm, sir, if you are done with this. I will show you how to do this. There is nothing you can see here in this code. We declare class A with set values, and we have defined two variables there, instance variables, and assigned with some values. And then we use display to print those instance variables, and then inheriting B from A, and we find sum by using variables of B in of A class in B here, not B of A class, A variables in B. Then we print it, and we try to inherit C from B. Now C has access to properties of B as well as A. Now if you see A and B, we are accessing from A class, and this C from B class, this one, and we are finding out some sum here, some product here in the C class with the method null, and we are printing result. Now I have created object for C and try to call methods of all the methods from A class to C class. So first you should call set values. Display is optional. If you don't call display, nothing happens. But sum is mandatory, and then you have to do multiplication. Okay. Right now, I just quickly test this code just to show you like the output of this program. That's all. Okay. Now, go to the run, then save. You can see the output here. Can you see? 10, 20. This is from A class, 30 is from B class after doing sum of AB, and 6000 is from C class. 30 is from B and 6000 is from C. This is a product of ABC, 10, 20 and 30. You get this, sir, all of you? This is the idea about multi-level inheritance. So we can quickly finish remaining inheritances, sir. Okay, but I'm going to stop the session here today. We have some work here, so we'll finish off tomorrow this one, and also difference between a static method versus a class method, that is also there. First I will finish this and then go back to that discussion. Tomorrow we'll close off all this, and then I'll switch to polymorphism. So probably we are almost ending to the OOP, object-oriented programming. Now we have done core Python. We are almost at the end of advanced Python. Then we will see few more interesting topics here. That is regular expressions as well as exception handling, and then also connecting to the database. We look after all that, and then probably we will be ending this with here. Okay. Then we'll start with data science fundamentals like analytical Python, NumPy, Pandas, all that. Okay, that's how we proceed. Okay, is it clear for all of you? All of you are good, sir. Okay, guys, I'll stop here. Today there is some work for me. We can do one thing tomorrow. Is it comfortable for you if we do this session at 5 o'clock, not at 7? Is it fine? 5 p.m. is fine for all of you. 5 or 4 will be 4. Okay then. Yeah. So we'll do one thing then. Tomorrow, probably we connect by 5 o'clock. Clear? Okay, sir. Thank you. Happy weekend. See you guys.